for her sake. Okay, set. So done, huh? Okay, now let's go on to the next question. What is the reduction in set 2? Okay, what is the reduction in set 2? Yannick, have you found the paper already, Yannick?
What paper, sir?
This paper.
I sent back in the MC.
You sent already. Okay, teacher hasn't seen it. So if the rest of you here, you've got an iPad or your laptop or whatever, open it at the same time so that you can do as I'm talking, yeah? Okay, what is my reduction in this question here? This set 2. Okay, you already know this is my chemical equation. We did just now for those of you who came in late. Okay, so which one is undergoing reduction? Is it magnesium or is it iron 2 sulfate?
Is it iron 2 sulfate?
Okay, why do you say that? And if you don't know, just put in the chat, teacher, I'm not sure. Teacher, I don't know.
Teacher, I am not sure.
Okay. Yes, anyone else?
It's bromine water.
Teacher, we are doing question number 2, set 2 now. Set 1
Yeah.
done already. In set 2,
What? Set 2 is magnesium strip.
okay, so wrong. Okay, wrong. But it's good that it's wrong because then teacher can teach you why is it wrong. Okay, here it's so much easier if I show you how to do it by using the oxidation number. Anything that is a solid, liquid, and gas, your oxidation number is a 0. So is magnesium a solid? Hello, is magnesium a solid?
Yes.
I should be getting like 12 people answering me yes. Okay, so magnesium is solid, your oxidation number is a 0. Is iron a solid?
Yes.
I cannot. Okay, yes. So it should also be a 0. I'm talking about the oxidation number, yeah? Okay, now we look at iron and we look at sulfate. Okay, iron and sulfate, teacher wants you to break them up into its ions. Iron 2 sulfate. Okay, what is the charge of iron here? If it's an aqueous, teacher can break them up. So what is the charge of iron here? You don't know?
2 plus.
Very good. It is +2, yeah? How many of you don't know? Don't be afraid of your friends or whatever. Your exam's already on Wednesday. So if you don't know, just say, teacher, I don't know. Because iron can only have two answers, either 2 plus or 3 plus. Why is this one a 2 plus? So I'll say it for the sake of those of your friends who are too afraid to say it, yeah?
Iron 2.
So, sorry? Okay, yeah.
Yeah.
Did you say something, Yannick?
No, sir, because I don't know how to explain it, but because the oxidation number is 2 plus, so or sulfate also the oxidation number
Minus, yeah.
so
You're going to
minus out.
cancel it. Correct. So that's why it's 2 plus. Okay, what's the oxidation number of sulfate?
2 minus.
Okay, -2 is correct. Okay, what is the oxidation number of magnesium?
2 plus.
Okay, what is the oxidation number of sulfate?
2 minus.
-2. The rest, teacher want to hear the rest as well? Okay, so you now from one magnesium before the arrow, go to the magnesium after the arrow. So we do this together. I'm going from magnesium before the arrow to over here. Now look at the oxidation number. The oxidation number is changing from 0 to +2, correct or not?
Yes.
So if it's going from 0 to +2, is it reduction or oxidation?
Oxidation.
Oxidation. Oxidation is when my oxidation number increases. Remember that, okay? Now look at iron. Iron, I'm going from +2 to 0. +2 going to 0. Now +2 going to 0. My oxidation number is decreasing. So it's undergoing oxidation or reduction?
Reduction.
Excellent, reduction. Now do you understand, class?
Yes, teacher.
Okay, now they're asking you, go and write down the equation for me. the equation for reduction. So actually it's not so difficult. You know you're starting with Fe2 plus. You know you're ending with Fe. You know in a reduction you're going to receive electrons before the arrow. All in front of you already. Write down the equation.
Fe2 plus 2E minus
Okay. So I'll go there for you, yeah? It is, okay, go ahead, tell me, Yannick.
Fe2 plus
Mhm.
2E minus
Mhm.
rho Fe.
Very good. Okay, I hope you understand my writing, the rest of you here. Yes, the answer is correct. Okay, Fe2 plus 2E minus, you are going to get Fe. Class, do you understand? I'm assuming you all
Yes,
understand.
Yes.
Okay. I don't know if I'm laggy or you're laggy. Is teacher laggy for you?
No,
No,
teacher,
no,
not
Teacher.
Okay, what's the function of iron 2 sulfate here? What is the function of iron 2 sulfate? Look, you look here already, you know. Iron 2 is undergoing reduction.
oxidizing agent.
Rising agent.
Oxidizing agent.
Sorry, Joshua, didn't hear what you said. What do you say?
Oxidation agent. I mean oxidizing agent.
Correct. Oxidizing agent is correct. Okay. Set
But
1,
that's set 1.
or they asked for set 1 and for set 2.
Set
So you
1
gave
is
me for set 2 oxidizing agent, correct? Okay, let's go to set 1. Okay, in set 1, it is undergoing oxidation. So if it's undergoing
Reducing
oxidation,
agent.
it is my
Reducing agent.
reducing agent. Okay, so that is one very simple question that teacher has done with you all. Okay, I think that's the end of the question. Now you are going to try a YouTube for me. The concept is the same. You can do that. You can do any question. Okay, let's look at this. You talk to me. You tell me what information I must write down here.
Must you identify which is oxidizing and
Okay, Joshua, you tell me one. If you know, if not anybody else here.
the acidified potassium manganate 7 solution is the oxidizing is undergoing oxidation
No?
or is the oxidizing agent. I
Yes,
can't
correct.
remember.
Remember
Yes.
AABC.
Yeah.
AABCs are my oxidizing agent. Okay, another person. Any more information that I need to write down here? You all
change
cannot
in
be.
color, chef.
Can I go, Cha?
Yes, you can talk about color, yes. Okay, if one is my oxidizing agent, the other one is my
Reducing agent.
reducing agent. Okay, you want to give me color? Go, Yannick, color?
Green, teacher.
Very good. What is green? Teacher's not green.
Iron 2 sulfate is green.
Okay, it will. What do you think it will go to? Green will change to iron 2. Surely will change to iron what?
Iron
3.
3.
Brown.
Very good. It will go to brown. Okay, good job. So far, Joshua, Yannick, Shamira. Okay, can I hear the rest? Okay, acidified potassium manganate 7 solution. What color is it changing from? What color to what color?
Purple to colorless.
Okay, purple to colorless. Correct. Give me my half equation now. See, even before I look at the question, I already can answer so many things. Clever. Okay. Give me the half equation for each of it.
Teacher, for acidified potassium manganate solution, how do you
Your
write?
favorite, right? You all like to memorize this, right?
Like this very long, chef.
MnO4 minus plus
Plus O as a whole.
who memorized this? I told you all to memorize, right? Okay, we do this together. In case in exams happens again, we try this together, okay? So you're going to get an Mn2 plus. If you know you got oxygen
Is it
here,
8H plus?
sorry?
Is it 8H plus?
Okay, it's not 8H plus.
H2O, is it H2O?
You're going to get H2O here. Yes, correct. So I've got
H2O.
4 H2O is correct. Did you say 8 just now, Yannick?
Yeah, my bad. chef.
Correct lah.
Correct, chef.
No, you said 8H plus or 8?
Yes, chef.
Correct.
Yeah,
Okay,
it's
so
8H plus. Chef.
sorry. Teacher didn't hear properly. Okay, 8H plus. Okay, now my electrons.
5.
Correct. Are y'all looking somewhere or y'all doing it on your own?
So I got some notes here, but but I can't understand
You know,
my.
I'm doing it on my own. I have no notes here.
Okay, so it's very good that you can actually do it on my own. I feel that I'm teaching 2 students, but I know so many of you are there. I would like to hear from you. It's
Come on,
that I know that
Ladini.
everybody understands, but it's very good that Henning and Joshua's talking. I don't feel that I'm talking to myself. Okay, excellent. So keep it up. The rest of you, let me hear your voice. Shamira, Alia, Dini, Varshani, I know you're there. Let me see who else. Azim.
Sure, Kavi needs you.
Kavi left already, I think. Where's Kavi? Oh,
No,
Kavi's still here.
Kavi.
I'm here too, I'm here.
Okay, no worries, no worries. It's okay lah. As long as y'all are here and just say something. Okay. How to get this? Very simple. I know I've got O here, so I must have water. Okay, and then to make the O force, I have to put 4 in front here. Okay, that means my hydrogen here is 8, which means I have to put a 8H plus here because acidified potassium manganate. Okay, and then here is -1 plus 8. Okay, so watch out. -1 plus 8, and then here is plus 2. So -1 plus 8 is how much?
7.
7. Okay, so plus 7. Teacher need to balance. Both sides must be the same number. So here teacher got plus 2. How to make this side plus 2? Teacher plus 5 electrons. Okay, so 7 plus 5 is 2. Okay, you must be thinking, teacher, how on earth 7 plus 5 is 2?
7
Okay, I know
plus
your maths is bad, but how come it got very bad? Okay, because 1 electron is -1, 5 electrons is -5. So it's actually 7 minus 5. Okay, so you get plus 2. If let's say you still cannot get this, I would really suggest that you memorize it. Okay, now what are the color changes here?
purple to colorless.
Okay, purple going to colorless. All right, so just going to go to the first question. What is the color of iron 2 sulfate? Doan,
Green.
Joshua, and Yannick.
Green.
Green.
Sorry.
Green, okay. Whose voice was that?
Mine and Joshua's.
Okay,
Yeah, I think
just
Kavi also spoke.
okay.
Right.
All right,
Got
Kavi. Okay, good. Next one. When the let's go to the English. When the circuit is completed, the galvanometer shows a deflection. What type of reaction is in the R electrode? What happens in my R electrode? What's happening there?
Oxidation.
Oxidation.
Joshua cannot answer. Yes, it's
sorry.
correct. Oxidation. Okay. Reducing agent must always undergo oxidation. I hope everyone else who is not answering, you are saying oxidation with the mic muted. Okay, I hope lah. Just turn on your mic. I don't mind. Okay, it's oxidation, correct. Okay, what is the observation for acidified potassium manganate 7 solution?
Purple to colorless.
Yannick, cannot answer, Yannick.
Sorry.
Correct, purple to colorless. I heard someone saying pink. Who said pink?
I just,
That one's phenolphthalein, phenolphthalein.
yeah,
Cannot.
wrongly.
All right. Okay, purple to colorless. Excellent. See, in this marking sheet, they rejected arrow. So don't put arrow. Don't put purple to colorless. Don't. Okay. What is the what is the change in the oxidation number of mangan in C1?
So you
So
did this just now.
sorry?
So you did this just now.
No, I didn't.
Huh?
So what I did is I gave you the half equation. This is a half equation. Question
Plus
is
7
asking.
to plus 2.
Yes, Sanjeev, correct. Very good. Okay, but the
Why the Indian accent, teacher?
sorry?
Why suddenly you got the Indian accent?
No, I was just trying to mimic his voice.
Oh.
Right? Plus 7 to plus 2. Do you know why or not, class?
Yeah.
Yes, sir, you
Without-
should.
Because 7 minus
Just
5.
show this
Yeah.
just now.
Yeah, you told
No,
us.
actually, that is not the
Oxidation number.
that is not the oxidation number of what I did here is nothing got to do with manganate here. But so happened, thankfully, manganate is also 7 lah. What I did here was I showed this is -1. That means the -1 here plus 8 gives me plus 7. That's it. But actually, in order for you to find out how manganate is plus 7 is you look at what teacher is doing now. I want to find what's the oxidation number of manganate. Okay, Mn plus, okay, oxide is -2 times 4 equals to -1. The sum of all this oxidation number is equals to whatever number is on top here. If I've got no number, that means it's equals to 0. So Mn minus 8 is equals to -1. Mn is equals to plus 7. This is the working. So it's different from what teacher did just now. Okay, then you get plus 7 to plus 2. Okay, two different things now. Please take note. Can come out in exam, this kind of questions for chromium after that. Okay, so we have done this, we have done this. Okay, now draw me the arrow of the direction flow, class. It will always flow from where to where?
Cathode to anode.
No such thing. How you know which one's my cathode, which one's my anode here?
Sorry, from
From iron to acidified potassium.
Yes, okay. The key point is this. I want everyone to jot down, write down somewhere. From reducing agent to oxidizing agent, because reducing agent is undergoing oxidation. So I've got electrons to donate. And it's going to oxidizing agent because it is going to undergo reduction. It will receive the electrons and then undergo reduction. So if teacher is going to be drawing the arrows, I am going to draw the arrow like this. Okay, so this is the correct way. You don't have to write reducing agent to oxidizing agent. In your mind, you must memorize that. And don't have to draw so many arrows. The amount of arrows teacher drew there is sufficient already. Okay, next question. Okay, now I want to see whether you can do this on your own. Okay, this is very similar, so I'm not going to waste time. I'm going to give you another YouTube question. Okay, and teacher's not going to help you. Okay, start now. Look at the question. Okay, draw it very quickly on your paper, or if you have the paper with you also, it's okay. Does everyone in this group right now have the paper with you? If you do, yeah, okay, on your phone, fine. Okay, so you know the question in front of you. Alia, Dini, and all, do you also have the question?
Yes, teacher.
Everyone, Kavi, Krisha, Mira. I'm assuming everyone has. Okay, go to question number 1. What is the function of sulfuric acid? Ta-da! Suddenly no one answering me.
Acts as a salt bridge.
0 marks.
between
The no
Allow
between.
movement of ions to
Allow
complete
ions to
complete the circuit.
Yes. Okay, Kavi, I think it's you. Go ahead, Kavi.
Acts as a salt bridge to allow the movement of ions to complete the circuit.
Okay, perfect, full marks there, yeah? Okay, to allow the movement of ions to complete the circuit. Okay, so this is a full mark. Acts as a salt bridge, actually not necessary. Okay, so anytime you see that question, okay, this is how you answer. Okay, let's go on to the next one. What is my half equation at x and y? You see already, you should know it was my first one. The first question was not even a YouTube question, but it's a similar thing that they are giving you here. Okay, half equation, teacher give you 30 seconds to do it. And if you want to try, just say, teacher, I want to try. I'll give you a chance to do it.
Teacher, can I try?
Yes, Josh. The rest
Yeah.
of you done?
Yes, teacher.
Then
2BR
teacher.
2 plus 2E minus equals to 2BR minus
So you are doing for
bromine.
electrode Y, yeah?
Yeah. So wait, my mother's at my door. Wait.
Okay, anyway, I heard him. He said BR2 plus 2E minus, I will get 2BR minus. Class, did you also get this as well?
Yes, teacher.
Okay, very good. Who wants to do electrode X? By now should be very fast already. Dah cepat already, can do very fast already. Who wants to go?
Is it Fe2 plus arrow Fe3 plus E?
Very good, Dini. Okay, so both also correct. Sorry, not Dini, Alia. Okay, very good, Alia. Okay, good job. Sorry, Alia. My mind was thinking Alia, my mouth says Dini.
Okay,
Okay,
teacher.
sorry. Okay, so now what is the change in the oxidation number for bromine water? Joshua cannot answer. Alia cannot answer. Yannick, you can answer. Or the rest can answer.
0 to oxidation number.
Sorry,
Is
yeah.
it 0 to -1?
Okay, correct. It is 0 to -1. Kavi, was that you, Kavi?
Yes, sir.
Okay, correct. 0 to -1. Don't put arrow, yeah? Remember, don't put arrow. Nowadays, write it down. 0 to -1. We don't know how these people suddenly they want to change their mind, don't want to give
So
arrow.
why
Oi.
not, sir? I don't understand.
Suddenly they can change the marking scheme. Arrow tidak dibenarkan. Suddenly. Okay. So we just be careful. We write in words. Okay. Marking scheme changes year by year.
Sure, our syllabus also change year by year, sir.
All right. Now, I think this question only. Okay, I think you already know how to do this. I'm going to give you one more YouTube, then I'll go to voltaic cell ready. Can I find one more YouTube for you?
Yeah, sir, you just pass this thing.
No, that one is not a YouTube. You all have the paper with you as well. If you can search together with teacher. Okay, got it. Didn't we, your Selangor paper? Isn't it your Selangor paper? The one
sir,
you
that
set for
was-
exam.
Yes, sir, that's our trials paper.
Okay, do again. See how you're fair now? Okay, after trials and before trials. Okay, quickly, then teacher wants to start voltaic and then after that electrolytic already.
Teacher, do
Okay, I'm
our
not
trial.
helping you, but teacher's giving you 2 minutes to do it. 7:56. This is on page 32. Okay, page 32. So it's not even much also as well. Okay, it's really not a lot. Okay, it's just very simple.
It's
2,
23.
yeah? Sorry, 3, yeah, but
Teacher,
teacher will
not-
add on
teacher
later
is-
myself.
teacher is
Bit
not
more.
on
It's
page
23.
32.
Is it?
Teacher is not-
30, 32, 32 and 33. Is it the same with y'all?
Twenty-
Probably different.
23.
Okay, for y'all is 23. Okay, for y'all is 23 probably.
Yes, sir.
Okay, 23, start now. That's boogie woogie.
So can I do question number 1?
Yes, you may. Earlier on also we had the same question and we said, oh, too bad Joshua's not here. If not, he'll be answering that question. Wait, let me just reply Nakia first. I'm recording for her. Done? It's such a good question, yeah? It's really a good question. I can further ask you a lot more questions there until you can get 10 marks even. If you're done, put in the group done, teacher.
So do until question.
I think you only can do until question A. B we do later. I haven't taught you electrolytic yet. I want to go step by step. Voltaic first and then electrolytic. So we need to speed up a little bit more.
Teacher done, sir.
Okay. Everyone else done? If you can put it in the chat so teacher will know.
Then teacher.
Okay. Alia, 2 done. Anyone else?
Thank you, sir.
Okay. 3, at least 2 more, and at least 10 teacher will go on.
Done, sir.
Okay, 4.
And sure.
Okay, 5. All right, 6 in the chat. All right. Okay, so let's look at question number 1. Okay, Joshua, you may go. Proceed, please.
A chemical reaction where oxidation and reduction occur simultaneously or at the same time.
Very good. So I want you all, each time you all are doing the definition question in the exam hall, I want you to go and look at Joshua and then write down. Okay? The examiner is going to look at you all weirdly, but never mind. Just
You're gonna give us 0, Chair.
There is all Yannick sitting right in front there.
Okay,
He
just
must turn
imagine.
around, he must stand up, and then only he can look at me.
Okay. I mean, just remember Joshua and all his definitions. Remember all his right definitions and not the wrong one, okay? Not the mix-up ones at all. Okay, next one. What is the half equation for, sorry, what is the function of iron 2 sulfate here? What agent?
Reducing.
Reducing.
Okay, reducing agent. And the other one? Potassium manganate? Oxidizing agent. Okay, correct. Oxidizing agent. Perfect. You got 2 marks already there. Okay, next question. Okay, what's my half equation in electrode Y? They asked only for electrode Y, but I'm gonna ask you more later. And good thing I made you all memorize just now, isn't it? Okay, who wants to tell me the
Me.
answer? You all better pray it comes out for exam. Penat you all memorize. Okay. Okay, go ahead, Joshua.
See, I'm not referring, so I might be wrong. So
Okay, try.
MnO4 plus
Minus
MnO4 minus plus 8H
plus
plus 5E minus arrow
N.
Mn2 plus 4H2O.
All right, give me one round of applause. You did it. Okay. Now, equation also, you all stand up and look at Joshua, okay? All right. So, and you would have gotten full marks here. Okay. So, 3 to 4 marks. Okay. I'm going to ask you all even more questions because I think it's really unfair that they don't ask. Okay. What is the oxidation number change in electrode X?
+2 to +3.
Correct. +2 to +3. What is the oxidation number change in electrode Y?
+7 to +2.
Okay, correct. +7 to +2. What is the color change in electrode X?
Green to brown.
Okay, correct. What's the color change in electrode Y?
Purple to colorless.
Okay, purple to colorless. Okay, I'm gonna give you all a really hard one. Okay, give me the ionic equation. Oh no, give me the half equation for electrode X.
So we did this just now, right?
Yeah, do it again. Only for electrode X. You did electrode Y. Give me the half equation for electrode X.
Fe2 plus 2E minus.
No, wrong. Got it wrong.
Fe2 plus arrow Fe3.
Eh.
Yeah,
Ah,
Yannick,
no,
continue. Yannick.
Fe3 plus 1E minus.
Correct. Okay. Now, why I asked you to do it both, class, write down for me the whole ionic equation for this whole experiment. That means you take the 2 equations, you cancel off the electrons, and then write down the whole thing back again for me. How many of you don't know what I just said?
Can I try?
Yes, go ahead. Who is this? Yannick.
Uh,
Yannick, right?
Yes,
Yes, Yannick too.
Okay, go ahead.
Fe2 plus 4 minus plus arrow Fe2 plus and plus OH2.
Teacher, I don't understand. Yannick's voice is too deep, chair.
Yeah, that's why I had to ask who is this, because normally I hear the deeper voice and then now it's a bit louder. Yannick, did you cancel off the electrons already?
Yes.
Okay, so I think maybe I will get you to write down both for the sake of those people who maybe don't know what we are doing, okay? So the first equation is Fe2 plus F arrow Fe2 plus electron. What's the second equation, Yannick?
The second equation is 4 MnO4 minus plus 8H plus E minus arrow 4 Mn2 plus OH2.
Okay, correct. Okay, Yannick, what's the first step that you're gonna do?
Cancel the electron.
Did you cancel the E and the 5E just like that?
Yes.
Wrong.
Make it balance.
Chair, no, got bell.
You need to times the first equation with 5 first. The electrons must be the same number, then only you can cancel it.
Yes.
Okay, so very good try though. Okay, he did try, but then let's balance it first. Okay, Alia, what do I do next?
Times Fe2 plus equation tu dengan 5.
Okay, 5, 5, 5. Okay, next.
Then cut the electron.
Okay, one must be before the arrow, One must be after the arrow. Then it is correct. Now, in an ionic equation, all of you writing in an ionic equation cannot have electrons. Cannot. You're not allowed to have electrons. Okay? All right, carry on. Give me the answer. Or anyone else that wants to repeat, go ahead after Alia. Anyone else who wants to finish this? Okay, if not Alia, you go ahead.
5 Fe2 plus plus MnO4 minus
Mhm.
plus 8H plus
Mhm.
arrow 5 Fe3 plus
Mhm.
plus 4 Mn2 plus plus 4 H2O.
No, there's no 4 Mn2 plus, Only Mn2 plus
Mn.
only.
Yeah.
Plus 4 H2O. Teacher
H2O.
wrote down the 4 just now wrongly. Do you understand, class? Do you look at the last equation here? Can you see any electrons here?
No, teacher, can I ask a question? Instead of writing the first half equation, can you write the MnO4 first?
Can, no problem. That's not a problem.
Okay, teacher, thank you.
Okay, so this is called an ionic equation. Okay, I am going to stop here for this kind of questions. I'm now going to go to voltaic cell and then electrolytic cell. Yeah, so I'm gauging 20. Many of you, you already understand the system. You already know how to do, just need to do more practices. Okay, electrolytic cell is the one where you struggle a little bit more. Okay, show you Excel question.
Page
Now this
11.
one,
Go.
what dear?
Page 11.
Which state?
Wait, Asha.
Pahang.
Oh yeah,
Not
different.
Pahang, not Pahang.
It is but it's both combined. Je.
Okay, this one. I think it's this one. Okay, but I think I will skip this one because I think there's another one that y'all can do. Not this one either. It's a lot of electrolytic this year. Can y'all find? I think we are coming to it. We are coming to it. Okay, here. All right. Putrajaya 2207. Okay. Putrajaya is what page for you?
You is that essay?
Yeah, this is the essay. Yep, it's the essay.
There is one. There's one structure. We'll take.
But half structure only, right? Is part of another question, right?
No, Chair. It's one whole question.
Got where is it? Oh no, this is a structure. Sorry, this is a structure. No, I think this is a structure. Putrajaya.
Okay.
Is it? Are you?
2021 lah, Chair. The one I'm looking at.
Okay, does everybody see this together with teacher, or is it I'm the only? Question 7.
Teacher, where is
Question
this, teacher?
Putrajaya, you need to find the state. You need to go and find the state.
Yeah, Chair.
Unfortunately, my page and your page is different.
So what page? It's relatively almost there, but where is it?
Mine
19.
is on page 27.
It's page 19.
Okay.
Okay, yeah. Found it here.
Okay, so it's page 19 for y'all. Okay. Let's have a look, yeah? So I've got zinc, copper, dilute sulfuric acid, zinc sulfate, copper to sulfate, beaker, connecting wire, voltmeter, glass tube. You are supposed to use these materials and draw the setup apparatus to produce electricity from a chemical reaction, So when you look at these kind of questions, you look at all the materials here. Is it an electrolytic cell or is it a voltaic cell?
Voltaic.
Correct, it's a voltaic cell. A voltaic cell is also called a chemical cell. Okay, now, can someone tell me if you don't know how to draw? Teacher, I do not know how to draw a voltaic cell.
Teacher.
Okay, Joshua. Okay, besides Joshua. Okay, so the rest of you do know, right? Okay, I give you 30 seconds, draw now. Zinc will go in zinc solution. Copper will go into copper solution. Now look, I've got a dilute sulfuric acid. The dilute sulfuric acid is used with the glass tube. Okay, the glass tube is your salt bridge. Okay, whenever you have two different solutions, That means you've got 2 beakers. When you've got 2 beakers, then then you must have a glass tube. All right. Do you, the rest of you, you know what I'm asking you to do? You know how to draw?
Kind of, Chef.
Did you say no?
Kind of.
Okay, all right. So this is actually a voltaic cell. Okay, this is a voltaic cell. Okay, you're going to take one metal, okay, and you're going to dip it into one solution, which is, of course, you're using zinc. Zinc will go into zinc sulfate. And then copper will go into copper 2 sulfate solution. Now, because it's separated by 2 beakers, therefore you must use a salt bridge. Okay, so what are you using here for your salt bridge? You're going to use the glass tube here. Okay, and then you're putting in dilute sulfuric acid. And that's it. Okay, and then the wires and the voltmeter here. So you must have a functional diagram, you get 1 mark, and you label it, you get another mark. Okay, are you all okay with this? Do you all know what teacher is saying here? If yes, then we go to question number 1. Okay, all okay, huh? Some people have,
Teacher, how do you decide which one's the anode, which one's the cathode?
okay, I'm going to go there shortly, okay? How to know which one is the anode, which one is the cathode. So I've got zinc and I've got copper, okay? Now, between zinc and copper, how do I know which one is the anode, which one is the cathode? The one that has the more negative value, more negative E0 value, that's my anode. The one that has a more positive value, that's my cathode. Okay, so zinc, the value memang is more negative. Copper, the value is memang more positive. Another way is you have to remember, in the ECS, the metal that is higher in the ECS, that's your negative terminal. The metal that is lower in the ECS, that's your positive terminal. Helpful?
Yes, sure.
Okay, all right. So here you will have zinc as your negative terminal and you have copper as your positive terminal. Okay, the ones that are here, okay, do you get the concept here? If yes, only teacher will continue. If no, no point teacher continuing.
Yes,
Which
sure.
more negative is negative terminal.
Yeah, the more negative, like here, teacher doesn't have the negative value. Okay, the more negative it is, okay, it
So
is.
just memorize the ECS and then
Yeah, but in exam, you cannot put the reasoning is ECS. Okay, in exam, you must say the E0 value of zinc is more negative. In exam, you cannot say the ECS of zinc is, I'm sorry, the position of zinc in the ECS is higher than copper, 0 marks. If in exam, they ask you, which one is your negative terminal and why? So you say zinc because the E0 value of zinc is more negative compared to copper. That's all. Got that? Can or not?
can, sure.
Yes, can, sorry.
No, don't worry. I think some of y'all are having bio also at the same time. I pity y'all. Probably y'all don't know where to listen. Okay. If you want to go bio, it's okay. One teacher doesn't mind. I have the recording. So if you want to study for bio, go ahead. Your guest also asked teacher that he wanted to go for bio. If you bio is equally as important as chem. So it's okay. Teacher's very fine. Okay. If you want to listen to bio half, listen to chemistry half, also teacher doesn't mind. Up to you. Okay. Teacher will still
So-
carry on for those
So
of them
will
who
you
are still.
send the recording in the group?
Yeah, I'll send it according to the group. So no problem.
I just realized that bio class.
Yeah. Yogis just told me. So he just texted teacher as well. So it's okay. Don't worry about it. I want to help those who needs help. It's okay if you all want to go for bio, but don't feel so bad if you want to go for bio. It's really okay with teacher. You want to go for chem, is really okay with teacher. You want to listen to both also is okay with teacher.
So
All
how
right,
to
I'm just wanting you all to know that. Okay, what's my solution here that the teacher is using for salt bridge here?
zinc sulfate.
Kepala otak engkau.
Dilute sulfuric acid.
Zinc sulfate is for
Sorry,
zinc.
sorry.
Okay,
Dilute sulfuric acid.
correct. It is sulfuric acid. Okay,
Sorry.
dilute sulfuric acid. That's correct. Yeah. Okay. Now, sorry. The next question is, what is the function of the salt bridge? And we repeated already, like doing YouTube again. What's the function, class?
To
So
convert.
is it to allow free moving ions in the reaction?
No,
Oh,
wrong.
Acts as a salt bridge
No need to mention X as a salt bridge actually.
to allow
To allow the movement
of
of
ion.
Ions.
to complete.
The
the
circuit.
circuit.
Very good. To complete the circuit. Alright.
Teacher,
Yes.
can I ask you the negative part is oxidation, right? It's same
Yes,
as
correct. Correct. It's very similar. Okay. The negative terminal will undergo oxidation. The positive terminal will undergo reduction.
Just that the YouTube, they're both in one beaker and
Yeah, actually it's just, but they are still separated with the dilute sulfuric acid at the bottom. So it's actually similar, very similar actually. Just they change the way one is in the 2 beakers, one is in a YouTube, one you pour inside. Yeah, they're just very tricky only. Okay, next. Okay, label the setup apparatus. Which one's my negative terminal? Which is my positive terminal? You tell me. Okay, zinc negative,
Zinc
zinc
negative.
positive.
Copper.
Okay,
copper.
copper, no problem. Okay, what's my direction flow? Let me go up again. What's my direction flow?
From zinc to copper.
The answer is here, yes, but the answer it is zinc to copper. If I were you, I would let you to take your different colored pen. Okay, don't take red though, and then do the labeling of the direction of the electrons. Okay. Next question. What is my half equation for the reaction that's happening at zinc?
Zn.
Okay. Zn then?
arrow
remember-
and
Zn
Zn arrows. Zn
Zn
2
2
plus
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 2e minus.
2e minus.
Okay, yeah. Shamira, do you want to say something, Shamira? Correct boys?
no, I wanted to say the half equation.
Okay, you do for
Sorry,
me the other
Shamira.
side, huh?
Sorry.
Sorry, Samira.
Zn arrow Zn2 plus 2 electron. In a voltaic cell, the anode, we always choose the electrode. Actually, I have anions always go to anode. I still have SO42 minus here, and I still have OH minus here, but nothing I'm going to choose. In the anode of a voltaic cell, forever and ever, the metal is more important. Okay, now let's look at my copper. Okay, what is my half equation at my copper here?
Cu2 plus
2e
2e.
minus.
Okay, left Shamira.
Sorry, Samira. Sorry.
Cu2 plus 2e minus arrow Cu.
Okay, correct. Okay, you're not going to choose the metal. I don't care about the metal here. I'm thinking about the cations going to the electrode. And here teacher got Cu2 plus and H plus. Plus, why I never choose H plus? Why am I choosing Cu2 plus?
Cu2 plus is more electropositive.
Your head.
Jadi short.
Wrong answer.
E
It's
not
correct.
value.
E naught value more positive.
Oh, E not value. Sorry, not E.
E naught value of Cu2 plus is more positive than H plus. Must always compare and answer in full. Okay, perfect answer. Yeah, all of you so far. Okay, so let's see. Correct. Okay, you've given me both answers. Oops. Okay, what is the name of the substance that's oxidized in the above reaction?
Zinc.
Obviously, you saw the answer, right?
No,
Okay.
because you know there is mine is negative, so that means it's it'll undergo
Must
oxidation.
say atom and ion.
What is that? Who asked me what? Kavi, you? What did you say?
Huh? I think
I didn't say anything. Chill.
Something.
I asked.
It was
Sorry.
Yannick.
Yannick, why your voice keep changing one?
See, because I don't know whether you can hear me or you cannot hear me. That's why sometimes I'm shouting. And
I
sometimes
think Yannick oftentimes he makes his voice more girlish so that we could understand him because his voice is too deep.
Okay, thank you. Not girlish lah, make it maybe more clearer lah. Okay, Yannick, what was your question?
Must you write like zinc ion and copper atom
Where?
as the answer? Or just can write zinc and
Oh, okay, zinc. Only zinc because the one that is being oxidized is actually before the arrow and it's zinc what?
oh, okay. Sure.
Yeah, all right. I'm gonna ask you a question. What's my observation in the negative terminal?
Teacher, the thing becomes thinner.
The thing becomes thinner.
Electron
The
becomes
electrons
thinner.
becomes thinner.
Please, don't write the thing becomes thinner. Oh my gosh, but yes, the answer is correct. What is my observation in the in my positive terminal?
Brown solid.
Can that person who
Yannick said brown solid is formed, but his voice.
Hey,
is
I
deep.
didn't say anything. Kavi.
Oh, Kavi. Kavi's voice suddenly deep.
Okay, the brown solid is formed is correct. Okay, well done to all those who have answered here. Okay, I'm going to give you another voltaic cell question, and it is this. Okay, now what's the difference between this voltaic cell and the previous voltaic cell?
So this one
solid.
has a copper electrode. No, this one
No,
both
solid.
is in. This one both is in the zinc nitrate solution. No.
Oh, sure, there's no salt bridge.
Yeah, there's no salt bridge, but what do they have?
They have a
Porous port.
Okay, a porous pot. The porous pot has the same function as a
Salt bridge.
salt bridge. Okay, same thing. See how they drew it. So make sure if they ask you to draw, you're drawing it correctly as well. Okay, so if you look at the
If they
question.
ask for salt, if they ask for the phosphorus pot, you just make sure that it is in the same beaker, just that it's like covered.
Yeah, so the solution for my copper will be inside the porous pot. So that means it's separated from the zinc nitrate. Actually, it's the same thing. I want to separate the solutions, but I still want the movement of the the movement of the ions to happen. Okay, I'm assuming he understood what I said.
Yes,
Okay,
sir,
what's
I
the
do.
what's the color of copper 2 sulfate class?
I'm gonna go for blue.
Sorry.
Blue, blue.
That's iron. Sorry.
Blue chair.
Blue?
Yeah, I'm gonna go.
Correct. Okay, what is all the cation ions present in the porous pot? Cation ions present in the porous pot here.
Cu2
And
plus.
H plus.
Okay, say that again.
Cu2 plus and H plus.
Okay, Cu2 plus and H plus, correct. Okay. Now, if ever I tell you there's an online class, right? Can you also share that with B as well?
Oh, yeah. So,
Yeah,
do
because
you want me to send it to them?
yes, I
okay,
don't know. I think some taking bio, so it's okay. Maybe my recording can send over lah. Because I have some of the kids asking if I can.
Do you want me to send it to the group?
Can you can send to them if you want. Yeah, I have some of the kids texting. Yeah, all right. Okay, Cu2 plus H plus, correct. With don't need to waste time about selectively discharge. Okay. Okay, all right. I love this. Write the cell notation for the reaction. Okay. Can Yannick? Okay, what's the cell? Bye-bye. See you, Yannick.
Teacher.
Okay.
Thank you, teacher.
What's the no worries. Okay, what's the cell notation for the reaction? How to do a cell notation? So the rest of you who are here, yeah? I have Azim, Ashwin, I've got Binny, I've got Joshua, I've got Kavi, I've got
Teacher,
Mira. Yes.
can I go for bio for just then I'll come back?
Yes, Shamira, go ahead.
So is
We all-
the cell
Thank you,
notation one
Chair.
got like the wall and the double wall?
Yes, correct. Joshua, don't you take bio as well?
No, sir.
Oh, you don't. Okay,
I'm
yeah.
like I'm like Ashwin, sir. We
Okay,
both
yeah,
don't.
like the Joshua's together. All right, okay, shoot. Okay, what is the cell notation for the reaction?
Is it Z
Correct?
Zn and then one line and then Zn2 plus and then double line and then Cu2 plus one line and then Cu.
Okay, correct. Now, I mentioned in the previous.
Chair.
Yeah.
Do you need to put like after Zn put
And the
bracket
physical
solid?
state. Yeah, Smell. I just remembered in the class I did it with
Oh,
you and Bin yesterday.
Okay, sir.
Okay, let's do it again. Okay, so there you go.
Zn
Mhm.
solid,
Okay,
one line, Zn2 plus equals
okay,
double line, Cu2 plus equals
okay.
one line, and then Cu solid.
Okay, correct. Yeah. So take note. Yeah. I want y'all to write the physical states again because we don't know what their marking scheme is. Okay. How many of you here, you don't know how to do this? You don't know how to do the, how to write, cell notation.
So I know.
Okay, you know, so I won't waste time. So cell notation, you already know. Next question is, what is the E naught value for the reaction? So how to find out what's my E naught value?
Do you refer to this
Cathode minus anode.
Very good. Okay, my E naught value is cathode minus anode. What's my cathode here?
0.34
0.34 plus.
Yes, very good. 0.34 minus 0.76. Okay, so I'm going to get, sorry, what's my answer? 1.10 volt. Did you all get that?
Yes, teacher.
Positive 1 point.
See,
Oh.
even better. Got the positive one there. So 1.10 volt. Thank you, Vin.
You're welcome.
Okay, so you must have positive, you must have negative. Okay, no positive, no negative, your answer is wrong. Okay, that's very, very important. So two things, the positive and the vote here is very important. Okay, move on. Okay, based on what?
Who is that? Who is iPhone?
I don't know, bro.
Oh yeah, I admitted iPhone, but I don't know who is that.
Who is iPhone?
iPhone, who are you?
Who is this? They don't
Who's
want to
that?
name themselves. Hello, iPhone.
Is that?
Is that?
Wait.
Is that?
I don't know any Izzat. Do you all know any Izzat?
Yeah, is that
5B.
5B?
5B.
Oh,
No, is that?
The one yesterday's class, he was sitting on the left.
Ideal friend.
Ideal's friend. Ideal's friend.
oh, okay. Now I remember him. Okay, let's carry on, yeah? Okay, so based on your answers in HC2, that means here, what should you do to the anode if I want to increase the E naught cell value? Teacher wanted to change maybe to 2.7 or 1.8. What should I do? So this one teacher is using zinc and copper. How can I change the value?
You use a high.
Yeah, correct. You're almost there. Think. You're
You
almost there.
You use a more
More correct. Go on, tell me.
positive E naught value.
Okay, it's actually you use a more electropositive metal, right?
Yes.
Okay, so you use a more electropositive metal and the metal has a more negative value. Okay, so his answer is correct. You replace the zinc metal here with magnesium. So we talk about the ECS. Magnesium is higher than zinc, correct or not?
Yes, sir.
Okay, so magnesium is higher than zinc. You have already a mark there, okay?
Teacher, what
And
if you
then
don't give like magnesium metal? If you just say replace zinc metal with a more electropositive metal?
because you know why? Because your I think they will still accept, but they will prefer that you be even more specific with them.
Okay, sir. Thank you.
Okay. They might still accept the marking scheme. Okay, then they ask you why. They ask you that you have to give a reason. The E naught value of magnesium is more negative than the E naught value of zinc. Okay, so that's your second mark, which is true. If you look at magnesium here, magnesium is negative 2.38. Zinc is negative 0.76, which means if I use that in an equation, so I'm going to write down that I'm going to draw the, I'm going to do the equation for you. I'm going to do the cathode minus anode. My cathode just now was positive 0.34, correct?
Yes,
Okay,
teacher.
minus negative 2.38. I want all of you to calculate this for teacher. What do you get?
2.72.
Okay.
Positive 2.72 volts.
Okay, positive 2.72 volts, and the answer is correct. Okay, when you get positive 2.72 volts, okay, you compare now. When I use magnesium, I get positive 2.72 volts. When I use zinc, I get positive 1.1 volt, which gives me the point. Okay, to increase the value, I must replace zinc with magnesium, or you can actually say replace zinc with the more electropositive metal. Then they will understand, oh, he gets the concept here. Okay, even if you don't say more electropositive in the first sentence, this sentence already brings it up. Okay, so that is the second concept here. Alia, do you have any questions to ask?
No, teacher.
Okay, so I saw another question that has a voltaic cell as well. Okay, I want you to try. Teacher's not going to help you. You're going to try it on your own cell. Okay. Too bad bio is happening at the same time with chem. You'll have to search as well. Do you all see a electrolytic cell? Sorry, a voltaic cell. Okay, this is nice. Would you all like to try this together with teacher? I think for y'all, it would be on page 30 something maybe. Selangor 2022, set 2, question number 11. Did y'all find it?
Wait, I'm
Yes,
trying
teacher.
to find it. Can someone tell me what page it is?
What's the page for y'all?
30, teacher.
30, Joshua?
Thanks, Alia.
Okay, so we try this together. I think Azim and Vin, we didn't try this question yesterday. So actually y'all can try together also.
Teacher.
Okay, let's try to do this together first, yeah? So on one side is a voltaic cell. On the other side is a electrolytic cell. Okay? Now, you tell me for the cell 1, which one is my anode, which one is my cathode?
W is the cathode, Z is the anode, and cell 1 is the. Hello, sir.
Wrong.
Why not W to Z?
Your zinc and copper.
You must name both, sir.
Teacher, why is the not a cathode?
Why?
Because zinc is sorry.
No, there's no
I
Y,
think,
W.
oh, W, yeah, sorry, teacher.
Wait, so is it WX is the cathode and YZ is the anode?
No,
Anode, right?
no. In cell 1, one of it is the anode, one of it is the cathode. In cell 2,
So I didn't see the
porous pot.
Yes.
Yeah. So the first one, we must do cell 1 first. I think iPhone wanted to say something. Izzat, do you want to say something, Izzat?
Nothing.
Okay, so I have zinc and copper. So we do cell 1 first. We just did it just now. Zinc and copper. Which one is my anode? Which one is my cathode?
Zinc is
Zinc
anode.
is the anode,
Very good.
copper is the anode, cathode.
Okay, and copper is my cathode. Correct. Very good. Now, anode is negative and cathode is positive. In a voltaic cell, zinc is negative and cathode is positive. Now you look at cell 2. Cell 2 is an electrolytic cell. In an electrolytic cell, I must have the battery. But where's my battery here?
Cell 1 is the battery.
Correct. Cell 1 is my electro. Cell 1 is the battery for my cell 2. So if this is a negative, I go here. Here is also my negative. And if this is my positive, I go here. This is also my positive. Okay, anyone blur or anyone lost of what teacher is saying right now?
No, sir, I get it.
Okay, very good. So now, if this is an electrolytic cell, you remember panic. Okay, panic says positive is anode and my negative is cathode.
Teacher, this is an electrolytic cell, right?
Correct, this is electrolytic cell. Okay, so this is my positive here. Okay, the one that is Y is my positive, my Z is a negative. Okay, good. Yeah, so clear whatever's happening in front of you. Can I go to the question now?
Yep.
Yes,
Okay,
teacher.
so identify type of cell 1 and cell 2. Cell 1 is what cell?
Cell 1.
Voltaic cell.
Very good. Voltaic cell. And cell 2?
Electrolytic
Electrolytic
cell.
cell.
Okay, yes, correct. Actually, Azim and Vin, we did this. Vin, yes, you can,
Yes,
Vin.
yes.
Yeah. Okay, Vin, you want to go for your dinner? You can go ahead. Yeah. All right. Okay. Next one. The next question is based on cell 1. What is my cell notation here? And then count my standard potential value. Okay. What's my cell notation? Soy. You look at this already. You should know. What's my cell notation here?
Teacher, for which one? For cell 1 or cell 2?
Only a voltaic cell can have a cell notation.
Okay.
An electrolytic cell got no cell notation.
Teacher,
Yeah, go ahead.
is it Z N and then brackets solid,
Very good.
then one line, right?
Mm.
And then Zn 2 plus
Mm-hmm.
aqueous,
Mm-hmm.
and then double line
Fine. Correct.
Cu2 plus aqueous, one line Cu solid.
Very good. Good job. Okay. And because we just did this just now also as well, here your E naught value teacher do for you straight away is positive 1.1 volt. No need to waste time. Okay. Because it's the same thing, right? I think all of you should know, isn't it?
This question they gave the diagram.
It's very similar to the one before.
Okay, okay.
Okay. Is Dini here? I can't hear Dini's voice at all.
Sure, Dini is here, sir.
Yeah, she is here. Dini, where's your? I can't hear you, Dini.
Yes, teacher.
Hi, dear. Okay, now only I can hear your voice. Dini, you can answer me. Yeah. Which one will undergo reduction in cell 2? Sorry, in cell 1, which one is undergoing reduction, Dini?
Reduction should be cathode lah, Cik.
Yes, correct. But you cannot tell me cathode. You must tell me which one. You must tell me, is it copper? Is it zinc?
So can I answer?
Copper.
Okay, he answered. Izzat says it's copper, correct. Izzat, why your voice is so breaky?
Because I am outside.
You are outside. Okay. Okay, so which substance undergo reduction? He said copper. Now I want to just clarify. He said copper. But actually, in a cathode for a voltaic cell, I don't look at the metal. What am I looking at?
Its value.
No. Your answer is copper. Your answer copper is correct.
Copper 2 sulfate.
Or you can say copper 2 ion is even better. Why? Because in the cathode, I'm looking at the cations going there, correct or not?
Yes, teacher.
Okay, so what are the cations going to my cathode here?
The Cu plus, Cu2 plus and
And?
H plus.
Okay, and H plus. Which one will be selectively discharged?
H plus.
Wrong,
Cu2
is
plus.
that?
Cu2
Yes, Cu2 plus. Why is it Cu2 plus?
Because the E naught value of Cu is higher than.
No. Okay, the E naught value of Cu2 plus is more positive. In a cathode, I'm always looking at the E naught value and it's more positive. Okay, is more positive, okay, compared to H plus. Okay, the E naught value of Cu2 plus is more positive compared to H plus. Go ahead, Kavi. You can go makan also as well. Okay, so the rest of you, you want to eat, you can go ahead, eat in front of teacher. You want to eat continuously, it doesn't matter, teacher still okay. All All right, so E naught value of copper is more positive compared to H plus. Okay, now let's go on to the next one here. So which one is being reduced? Cu2 plus or Cu?
Cu2 plus.
Okay, Cu2 plus is correct. Okay, now let's go on to the next question. They ask you explain your answer. Why? Why Cu2 plus? So whenever we do this kind of questions, right? Teacher actually like you to write down the equation. Cu2 plus 2E, I will get Cu. So when you want to explain, what do you see in this equation? What do you see in this equation here? What is happening to my copper 2 ions? Dini, try?
It's becoming solid.
Okay, very good, but you cannot say becoming a solid. You must-
Cu2 plus donates. I think donates 2 electrons.
Doesn't donate. It doesn't
Oh.
donate.
I'm
Isn't
not sure how to explain.
donating.
Sir.
Sorry?
I'm not sure how to explain.
Okay, now look at the Cu2 plus here. Cu2 plus is receiving electrons to become copper.
Hello, sir, sorry, I went out, sorry.
Oh,
It's
so
okay.
it's receiving.
Yeah, it's receiving electrons. Okay, so you look at the answer. Copper 2 ions gain 2 electrons to form copper atoms. Okay, so this is how you need to answer, yeah, in exam as well. Okay, all right, move on. Dini, Alia, Dini especially, I really cannot hear her voice at all. Okay, tak Dini?
Yes, teacher. Okay.
Okay, I want to hear Dini answering my next question now. Okay, Dini, tell me, which one is my positive terminal? Which one is my negative terminal, Dini? For cell 2. Okay, which one is my positive terminal? Which one is my negative terminal? Look at cell 2. Okay, look at teacher's cell 2 here. Which one is my positive terminal?
Y.
Very good. What's my negative negative terminal?
Z.
Okay, now class, everybody doing together with Dini. The question is, what is my observation in Y? What is my observation in Z? And right after this question, teacher will do an electrolytic question with you.
Cathode Z becomes thinner and cathode Y, I mean, what do you call brown substance is, am I correct or am I far?
Yeah, correct. You are getting there. So you say, because this one is a both copper, this is okay, this is a carbon electrode. So actually you're wrong. Okay, we are doing carbon electrode.
Both.
Okay, so when teacher has a carbon electrode, okay, so this is my anode and this is my cathode. Okay, now in my cathode, teacher will still have my cations going to my cathode. Who are my cations here? Cu2 plus, some more?
H plus.
Okay, H plus. Okay, now you look at anode. What are my anions going to anode? Teacher want to hear the rest as well, Alia. Luvan, if you're here, if you can, and if you're not in bio, okay, either way also can. All right, who is going to anode here? Okay, now teacher got
Anions.
OH minus and SO4 to minus.
very good. SO4 to minus and OH minus. Okay, so we've got 3 factors. Okay, factor number 1 is the factor of electrode. If you see carbon, you cannot say it's copper is wrong already. So I will never choose the electrodes. And then do you see anything says here concentration or concentrated or 1.0 mole per decimeter cube?
No, sir.
No.
If no, that's not the factor. So 3 factors that you must take note. Factor number 1, factor number 2, factor number 3. Factor number 1 is the E naught value. Factor number 2 is the concentration. Okay. In this question, nothing here says concentrated at class. Close it out. The next one is electrode. I don't see any copper electrode. I cancel it out. That means here I must choose my substances or the electron being selectively discharged based on the E naught value. So teacher do one by one first. Okay, so I'll go to anode first. I know I got OH minus and I got SO42 minus. Which am I going to selectively discharge OH minus or SO4 2 minus?
OH minus, chair.
Yeah, whenever you got OH minus and SO4 2 minus, never choose SO4. It's forever and ever and ever and ever going to be OH minus. Correct. Okay, so here we are going to choose OH minus. Very good, Luven. What is the equation for this? Empat orang hutan?
Hello, sir. Sorry, I think I disconnected. Hello, sir.
It's okay. And can be anyone else. What's my equation for this?
So is it the 4 or 4 OH minus?
Arrow.
2H2O.
Okay.
4E.
Plus.
H, yeah.
One more. Four orang hutan masuk hutan makan something, minum 2 botol air dan menghasilkan 4 ekor anak. What did they eat?
Orange.
How many oranges? I think
Ashwin, can you just answer, Ashwin?
Two. I think
You suspense.
what is that? What is that?
two
Two,
actually.
two.
Yeah, I think Ashwin is waiting for y'all to answer.
Oh,
So
yeah.
sweet.
Okay, the rest of you forgot already.
I'll memorize this. Next time you ask me, I'll be able to.
Alia and Azim forgot already, is it?
Yeah,
I
chair.
think berapa orange tu?
Tak ingat
I
apa
forgot,
orange.
chair.
Ayo, how lah you can forget? Exam bila, I'm going to shoot you already. Okay, so 4 orang hutan. So this is my equation. I'm not going to choose SO4 to minus. I'm going to choose OH minus. If the question asks you why are you going to choose OH minus? Why you didn't choose SO4 to minus? What's your reason?
It's
I told
what was the question, chair?
the question is, why am I choosing OH minus and not SO4 to minus? It must go back to my factor.
So I don't know the factor, but I think it's because more electronegative, I guess.
No, the factor is E naught value.
Not
What about the E naught value of OH?
the OH the E naught value in OH is more positive than
Negative.
more
And not
negative. Sorry, than SO4 2 minus. SO4.
correct. Okay, so the E naught value is always in I have more 5B students and 5A students currently in the class right now. That's what I'm saying. I'm just noticing Aiman also just came in. The E naught value of OH minus is more negative than the E naught value of SO4 2 minus. Correct. Okay, perfect. That's the answer. Okay, let's go to Cu2 plus and H plus. Which one am I going to choose? Cu2 plus or H plus?
H plus. Sorry, Cu2 plus.
Plus,
In-
right, chair.
Sorry.
In order for you to answer this question, right, you must think about the ECS first. Think about the ECS. The lower it is in the ECS,
The higher the E naught value.
no. The lower it is in the ECS, that's which one I'm going to selectively discharge. Okay, so Cu2 plus and hydrogen. Which one is lower in the ECS? All of you memorizing kalau nak kahwin now, right?
Yeah. So I'm going through kalau nak kahwin.
You're still calculating kalau nak kahwin. So between Cu2 plus and H plus, which one is lower?
Cu2 plus is more positive, friendship.
Yeah, but which one is lower in the ECS?
I think
Cu2 plus.
Correct. It is Cu2 plus. Okay. That is a quick way. Think about the ECS, find out which one is lower. That one I'll selectively discharge. Okay, then if they ask you, why did you choose Cu2 plus? You cannot say ECS anymore already. ECS was just a simple way of you to choose. Okay, when you choose Cu2 plus and they ask you why, your reason should be, Ken, Joshua, go ahead.
Last Cu2 plus is more electropositive than H plus.
Okay, you cannot use the word electropositive. The E naught, because my factor is E naught. The E naught value of copper to ions is more positive than H plus. You're always comparing E naught value. Okay, so the E naught value of Cu2 plus, okay, is more positive than H plus. You're always and always going to be comparing the E naught value. Okay, so far so good.
Yes, sir.
Okay, yeah, don't worry if you need to go and eat. Teacher does understand that. Okay, but now they're asking you what's the observation here. So that's why you have to write the equation. So you know, okay, what's my equation for my cation here? You know you're going to selectively discharge Cu2 plus. What's my equation? Anyone that's left behind.
Cu2 plus.
Very good.
2
Plus?
Plus 2 electron.
equals to Cu.
What do you get?
Cu.
Okay, very good. So the question is asking now, what is my observation in electrode Y? What's my observation in electrode Z?
I don't know.
Zn arrow.
No. Teacher's asking you what's my
sorry.
observation.
So
What
is
is my
it brown
sorry.
solid form?
Very good.
It's-
In
oh.
Z is brown solid is formed, correct. And in Y,
Colorless gas
Colorless
bubbles.
gas.
very good, because I've got oxygen here, yeah. So colorless gas bubbles are released. Okay, so you can see how they ask that question. Okay, it's pretty good. I think the questions are really, really, really good. Okay, trick question here. Okay, electric energy can be produced by redox reaction. You are supplied with a lemon, a piece of zinc, iron nail, connecting wires, bulb to build a chemical cell to prove the above statement. So if you are supposed to, you're drawing a label diagram, and the arrows to show the direction of the electron flow. Okay, write the half equation and ionic equation. What's my oxidizing and reducing agent here? 8 marks. So how are you going to do this? 5B, I think you haven't done this before. Were you? No, I think maybe you have. Did Puan Kogi ask you all to bring lemon or grapes or whatever to school and then put in what?
No, I don't think so.
Okay, never mind. Today we do it theoretically, okay? So you can use anything, lemon, potato, tomato, ango, you name it, you can use it, okay? So you take it and then you're going to put, because they say iron and zinc, right? So you put 1 iron, 1 zinc here. The connecting wires are here, okay? And then the bulb, all right? And that's it. You already got a chemical cell here, okay? Because in lemon, teachers got hydrogen ions. Okay, so then they ask you to draw a label diagram. So you label everything. Okay, electrons will flow from where to where? From iron to zinc or zinc to iron? Think.
Zinc to iron.
Correct. Okay, zinc to iron. The rest of you, don't be afraid to answer. It's okay if your answer is wrong. Okay, because zinc is always going to be my anode and iron's always going to be my cathode. Okay, if it's my anode, I'm always donating electron. And if it's my cathode, I'm always going to be receiving electron. And that's it, correct. It is going to go this way, which is my write a half equation and an ionic equation. Okay, so let's see what did they say. Okay, so this will be my half equation for zinc, my half equation for iron, and then ionic equation. I told you just now, we are going to cancel off the electrons and you're going to get your ionic equation. Okay, I don't think this is difficult here for y'all. I think quite simple. Now we've got 5 minutes. Shall we try one electrolytic question? What, darling?
Can sure.
Oh, okay. Okay, y'all also search for teacher. Find for electrolytic cell. It's not so hard. Then y'all can do. Okay, find for a electrolytic cell. Shall we do this? I think I did with y'all yesterday as well. Let me see. Let me see if I can find a simpler electrolytic cell. Okay, y'all search for teacher as well. Some we did yesterday, teacher don't want to repeat it. Can you find one? Did you find one? But this one is so not so nice. And y'all did before. Or you're waiting for teacher. Faster, faster. You also can have teacher to find. Come on, y'all can do it. Alia, did you find one? Dini, did you find one?
Not yet, teacher.
Actually, if not, I just have to use oh, this is a good one too. But a hard one as well. Okay, this one is nice. They like to ask concentration questions. I'm not sure why. And I want to change the concentration question. Okay, now my last, so we tried the one that we did yesterday. Unfortunately, teacher want to change it, but I can't see. Remember, Azim?
Not sure, Chair.
Oh yeah, because actually the question is in the class group. If you can check it. Okay, I believe it's just because before your SPM 2021 paper.
Chair, the Johor one is.
Cannot find where Johor is already.
Chair,
Teacher
the
went up
class
already.
group. The class group.
Teacher already, sorry, teacher went to a different question already. I went to the one that I gave you yesterday. So look at page 23, I think for your page 23. Maybe you can snapshot that one and then send to me. See whether I can open it up here or not. Vin. Okay, the rest of you, are you here? The rest of you, can you see the question that teacher is showing?
Can, teacher.
Okay, good. Yeah, so we tried to do this. This is actually a very good question. And this is a typical electrolytic cell question because I've got a battery. Okay, so teacher want to hear your voice, yeah? Okay, circle with me the things you think that are important. Okay, no one's telling me what to circle. How?
Teacher,
Aye.
all of them, Chair.
Akil, is that you, Akil?
Yes.
Haven't seen you and heard you for a while.
Sorry,
Not
Chair.
all. You can't circle and everything. Okay, I'll shoot you.
Okay.
Okay, I know someone wants to say something. What is it? What's important? There's something so important here. It's a big keyword here.
The greenish yellow gas.
If a greenish yellowish gas, it only can come because of something. Something in the second line here.
The sodium chloride solution.
No, it's the 1 mole.
Oh, my bad.
It's okay. The 1 mole here is the one that is so important. Because it is 1 mole, that's why you're getting the greenish yellowish gas. If it's not 1 mole, you won't get the greenish yellowish gas at all. Okay? Okay, so let's figure this out on our own. Okay, let's start. Dini, the long line is called what? Oops, the long line here.
Anode.
Very good. So this one here, anode. If here is anode, this one is cathode. Okay, next one. Azim, who goes to the anode?
The anode. J.
Okay, anions go to the anode. Okay, if the anions are going to the anode, who are my anions here?
Anion, chloride. Ion.
Very good. Chloride and?
And hydroxide ion.
Okay, hydroxide ion. Okay, I heard somebody answering me also as well. If you want to answer, just say only. Okay, and why are you all so quiet when Joshua and Yannick are around?
Because we know they will talk to.
Okay, so the next one, the cation ions. Okay, who is going to my cathode? The cation ions. Who are there? What's my cation ions here?
Na plus and H plus.
Na plus and
H plus.
okay, H plus. And I don't think so. They are talking because of anything. I think they don't want they
Sorry to interrupt.
yeah.
What time? Until what time is the class, chair? If you don't mind.
Who is this? Luven. It's actually
Yeah,
until a long time, Luven, because I'm doing carbon compounds after this.
Okay, chair, sure. Thank you, chair.
Okay, no worries. Yeah. Anyway, Na plus, H plus. Okay, which one am I going to selectively discharge?
H plus.
Okay, correct. H plus. Very simple. On my right hand side, Cl minus, OH minus. Which one am I going to selectively discharge?
Cl minus.
Kuching, I mean Cl minus.
Yes, Cl minus. Okay. The rest of you, Dini and all, do you know it's Cl minus? Dini, Aiman, Alia.
Yes, teacher.
All right, perfect. Give me the equation now, Alia. Chop, chop. Half equation for Cl minus.
Cl2
Kepala
plus
otak engkau.
Cl
Tak boleh. Kalau kita mula
Ah.
dengan Cl minus, kena tulis Cl minus dulu. Cikgu mula dengan Cl minus kan?
2Cl minus
Ah.
arrow
Hmm.
Cl2 plus 2E.
Very good. Okay, so this is for here, yeah? Okay, very good. And then on the other side, can I have Leuven? What's my equation, Leuven, for my cathode?
Chair, I can't answer, chair. I'm in very tight spot, please.
Okay, never mind. Let me have Dini. Dini, memang I hardly hear her voice. Dini, go ahead.
Teacher, sorry, I don't know.
Okay, it doesn't matter, Dini. So I'm going to choose H plus, right? So how to answer this question is very simple. Just like just now, I'm going to choose Cl minus. Here, teacher is going to choose H plus. Okay, good. In a cathode, it always undergo reduction. That means I will plus the electron before the arrow. Then, teacher plus before the arrow, I am going to get H, would always give me a hydrogen gas. Now, teacher balance it. If here got 1 hydrogen, here got 2 hydrogen, teacher make it balance 2 here. And I also put a 2 here because I need to balance up the charges as well. So this will be my half equation for my cathode, and this one half equation for the anode. Dini, do you understand now?
Yes, teacher.
Okay, now the question is very simple. What are the ions? I go to the English version. What are the ions attracted to the electrodes? So you gave me the answer just now already. You said to the cathode, you give Na plus, H plus. And ions, okay, you all give me the answer. Who is going to the anode?
Cl minus. Cl ion and OH ion.
OH minus ion, correct.
OH minus.
Okay, very good. So I have the answer. Now the next question, which one am I selectively discharged and which and why? Okay, so tell teacher, which one is being selectively discharged? Also, we went through that already. Another person answer, teacher. Between Na plus and H plus, which one is selectively discharging?
Na plus, chair.
Wrong? We just did it.
Oh, H plus. Oh, yeah. Wait.
Apa lagi?
H plus is correct. And between Cl minus and OH minus?
Cl minus.
Okay, Cl minus is correct. Okay. That asks you why? Why are these being selectively discharged? Okay, which one? Why is Cl minus being selectively discharged on one side And why is H plus being selectively discharged on the other side? Let's start with Cl minus. Why is Cl minus being discharged here? Why not OH minus? Why?
The concentration.
Yeah, correct. I want besides Vin and Azim to answer the concentration of what? Not many options here. You only got Alia and Dini and Aiman. So Alia, you can try.
The concentration of hydrogen ion.
No, we're not doing hydrogen. We are doing chloride here. Chloride and hydroxide.
The concentration of chloride ion is more higher than hydroxide ion.
Perfect. Okay, very good answer. Okay, that's why I'm choosing between Na plus and H plus. Why am I choosing H plus?
The concentration
No,
of
no. Concentration only affects Cl minus, Br minus, and I minus. So the factor in electron Y is concentration factor. But in electron X, no, I am not getting any concentration factor. Okay, the factor here is actually the E naught value. Okay, so between Na plus and H plus, teacher choose H plus because
the inert value of H plus is more positive than Na plus.
very good, Alia. Good job. Okay. The inert value of H plus is more positive than the inert value of Na plus. Sometimes they ask this in question, what is the factor for electrode X? What is the vector for electrode Y? Okay. And you must make sure you're careful enough to answer them. Okay. So very good answers for both. Yeah. And half equations. Yeah, you got that sorted out. Okay. Well done. Okay, so I will give you maybe a 2-minute break for you, of those of you who are still here with me. And then teacher will start with carbon compounds. Okay, if you want to study carbon compounds, join ahead. If you feel teacher, my carbon compounds terror already, no need, then it's okay. Teacher doesn't mind, up to you, yeah? I don't know how Leuven is in a tight spot. Leuven, what happened? You're on bio one side, is it?
Yeah, that's one chain. I'm in a restaurant, sir. So yeah.
I don't know how. 3
triple
phones.
tasking.
One, bio here, chemistry here. Okay, not bad lah. He must be really able to do that. So I'm going to stop this recording.